Okay, so we are going to finish the definition of the derivative today. Then we will look at practice problems for the exam on Thursday, and then we are going to have the exam next Tuesday. I don't know why the room got rearranged. It's still the same number of tables I counted, but yeah. All right, so we have our definition of the derivative. F of a plus h minus f of a all over h with the limit as h approaches 0. This is defined to be f prime of a. That's how we read f with this little tick mark of a. That means the derivative of f at what? Oh man. This is this. Okay. Well, I hadn't actually drawn anything. I was just reading it. There we go. So this particular question has given us two different a values to mess around with. So we can plug in the a value and do the limit for each one, or we can find the derivative in general and then plug in the a values to get the slope at each a value. So I'm going to start it off by plugging in the a value so we get practice and warm up with that. But then I'm going to do it for the general sense. So f of a plus h, so f prime of a equals the limit as h goes to 0. So f of a plus h is, we're going to take our function, so square root of 9 thing minus 5. And I'm going to fill in a plus h. Then we have minus f of a is the square root of 9a. And then we have all over h. All right, so this is the general formula for this question, and this one can be a little annoying to solve in the general sense because of all the square roots. It's still workable, you just have to be careful with your algebra. So I could just solve it from here, so my final answer is in terms of a, or I can plug in an a value now, solve it in terms of the numbers, and then I'll have that numeric answer for the slope of the curve at that point. So computer copy paste magic. Ugh, not what I wanted. So the first value they asked us to work with was 23/3. So over on the right here, we got to figure out what 9 times 23/3 minus 5 is. Sounds like a great time for the calculator. So 9 times 23 divided by 3 is 69. So in this first spot, when I distribute the 9 through, still got the square root, but that'll be 69 plus 9h minus 5 minus the square root of 69 minus 5 all over h. So I have my 9h, 69 minus 5 is positive 64, minus, this is the square root of 64, which is 8, all over h. If I plug in 0 right now, though, I'm still going to get 0 over 0. So I still need a creative algebra step to help me work from here. So whenever we have square roots inside a limit and we're getting an indeterminate form, then what we need to do is multiply by the conjugate. That's how we deal with these square roots being a problem, especially when it's minus a number or plus a number. It's usually minus though. So my conjugate is the square root of 9h plus 64, but then it'll be plus 8. So we're going to multiply by that on the top and the bottom. So on top, I'll have the square root times the square root. So that'll leave me with 9h plus 64. The outer and the inner terms cancel out. And then we'll have minus 8 times 8 is 64. And then on the bottom, our goal is to cancel that h on the bottom. So we don't distribute through. We're just going to leave the square root as is. Now on top, the 9h plus 64 minus 64, those 64s cancel out. And now this is h times, and on top, that's 9 times h. But 1h on top, 1h on the bottom, those cancel out. Now that I've canceled out that h on the bottom, now when I plug in 0 for h, I'm not going to get an indeterminate form. I'm not going to get 0 over 0. Now I'm going to get a number. So that is our next step. So I will have just the 9 on top. On the bottom, I will have the square root of 9 times 0 plus 64, and then plus 8. So inside the square root is just 64, which is 8. 8 plus 8 is 16, so we have 9/16 is the slope of the tangent line at the x value of 23/3. So a whole lot of algebra work. All so we could finally plug in 0 for H. Now, since they gave us another value to work with, we can do all of the same steps we just did, but putting in 5/9 in place of the A value, or we could just work with the original limit in terms of A. Um, since there's only the two values, it's up to you, especially since we already worked it out once. But I just want to show you guys what it looks like if you do it in terms of the formula instead. So the algebra is going to look a little uglier, but it's also going to be very similar. So inside that square root, it'll now be 9a plus 9h minus 5 minus the square root of 9a minus 5 all over h. So the same thing we did before, we had to multiply by a conjugate. We're going to have to multiply by a conjugate here. So everything inside the square roots has to be the same, but the sign in between the square roots is what changes. All right, so again, the conjugate is the difference of squares. So we're only going to get the first times the first, the outer and the inner cancel out, and then the last times the last. So the first times the first, the square root times the square root is just going to be what's inside the square root. So 9a plus 9h minus 5. And then minus what's inside the second square root, which is 9a minus 5. Note the parentheses there. If you don't have the parentheses around the second part, it's going to mess up. Now on top, this minus sign in front of the 9a minus 5 is going to get distributed through. So I have 9a plus 9h minus 5, and then minus 9a and plus 5. So positive 9a minus 9a cancel out. Minus 5 and plus 5 cancel out. So the only thing left on top is 9h. That'll cancel with our h's. Now that we've canceled those h's, now we can plug in 0 for h. So we have 9 on top. Then that'll be the square root of 9a plus 9 times 0 minus 5 plus the square root of 9a minus 5. So what was 9h becomes a 0, so it's just 9a minus 5. That's square root twice. So that is our formula for the derivative for any a value. So if I plug in 23 thirds here and work it all out, I'm going to get that 9/16. Now the other number they gave us was 5/9. 5/9 is going to be a little weird. So 9 times 5/9 is 5. 5 minus 5 is 0. So we have 9 over 2 times 0. 9 over 0. This is undefined. But since 5/9 is the number that makes the inside of the square root 0, that is like the vertex, the starting point for this square root function. Square root functions are the inverse of a parabola, except you can only do the inverse of half a parabola. When you do the inverse function, though, it takes what was a parabola and turns it sideways. So the tangent line at the vertex of a parabola is actually horizontal. So when we invert it, the tangent line on the vertex of a sideways parabola is a vertical line, which has undefined slope. So it's a weird answer, but that answer in this case means we got the vertex. All right, so the homework for this section is 10 questions split between two different assignment names. But some of them can be kind of long and weird. We still got a few more examples though. Yes. So any value less than 5/9 doesn't exist on the graph because that's where the square root would be negative. So like technically anytime we write a square root function, the unstated but implied domain is you can only plug in values that would produce like points on the graph. So 5/9 is the starting point for this graph. So in the original function, like I plug in 5/9, I get 0. So when x equals 5/9, the y value is 0. So that is our starting point for the graph. Yeah. right, our next one, we have an annoying rational function. And they give us our more traditional definition of the derivative. But this one has a follow-up question. They also want us to write down the equation of the line tangent to the curve at this value. So this is a classic test question, although the function here is a little ugly. I haven't written the test yet, so I don't remember what the other professors have used for the function here. It might be a rational function like this. Like they're a little ugly, but not like horrible end of the world ugly. All right, so since we only care about the derivative at -4, I'm going to go ahead and plug in -4 for the A value. So all right, so f of thing is thing divided by thing plus 3. So my f of -4 plus h. So I'm going to have a big fraction, and then I'm going to have little fractions inside it. It's a pain to write. All right, so on top of this fraction, we have -4 plus h. All right, one of the things I'm going to do anytime I have like little fractions inside this big fraction, and the only thing on the bottom right now is an h, I'm going to take this h and write it as 1 over h times, and then I'm going to work with everything that was on top. So I'm just kind of rearranging it so I don't have a giant fraction with little fractions inside it. So I have -4 plus h on top, -4 plus h plus 3 will be h minus 1 minus -4 on top, and then -4 plus 3 is -1. So that is just going to become a 4. So we'll have -4 there. So our whole goal algebraically on all of these is to cancel that h, that 1 over h in the front. So I have two fractions here. I need to combine these fractions together. Once I have them combined together on top, I should see some cancellation until there's only an h left, and then I can cross out the h and finish the question. All right, so negative 4 plus h, that's the same as h minus 4. Just looks weird like that, so so I have h minus 4 over h minus 1 minus 4. Now, in order to combine the h minus 4 over h minus 1 with the 4, I need a common denominator. So I'm going to multiply this by h minus 1 over h minus 1. Now my denominators are the same, so I can combine this. But we're going to have to like watch out for some negatives. All right, so I got the common denominator. I shoved it all together into one giant fraction before I bothered with any distribution. So on top, this 4 I have in front of the h minus 1, that's going to get distributed through, but there's also a minus sign outside that. So I can really think of this as negative 4 that's going to get multiplied through. So that's minus 4h, and then it becomes plus 4 all over h minus 1. So now that minus 4 and that plus 4 cancel out. So I just have h minus 4h. So that's negative 3h on top over h minus 1. And now I can plug in 0 for h now that I finally canceled that 1 over h. So this will just become negative 3 over 0 minus 1, which gives us a slope of 3. So all of that work, f prime of negative 4 equals 3. So 3 is the slope of the tangent line. At x equals negative 4. Now, the follow-up question here, which the second half of the web work homework does, and what we also ask on the test, is the equation of the line tangent to this curve at the value that we just worked with. So in order to get the equation of the line, I have the slope. I also need the point where this line is going through. Right now, all I have is the x value. So I need to figure out what f of negative 4 is. So that'll be negative 4 over negative 4 plus 3. So negative 4 over negative 1, so 4. So f of negative 4 is 4, and the slope is 3. So the formula for getting the equation of a line I go with this one. That's just my habit. So our x value is -4, our x1. The 4 we got at the end, that is our y1 value. And then that slope we got before was 3. Now, technically, that's enough. But WebWork is probably going to want you to type it in y equals mx plus b form. So we're just going to clean it up a bit. So x minus -4 becomes plus +4. And then we distribute the 3 through. So 3x plus 12. Add the 4. That is the equation of the line tangent to the curve at a equals -4. So there is a whole lot of algebra work on these questions, and it can get it's really easy to get lost in all of the algebra work. So when you finish a problem like this, it's helpful to go back and just kind of think through, like, what was I doing? Why was I doing it? So they asked us to find the slope of the curve at the given point. And the given point was a equals -4. So we used our definition of the derivative. We did our -4 plus h, substituted that. Then we did f of -4, substituted -4. And then we had to get a common denominator. Got that together, finished that algebra work, finally canceled the h's, and we got a number at the end. That number is the slope of the curve at a equals -4, or x equals -4, whatever. Then the last part, equation of the line tangent to the curve. We had to remember y minus y1 equals m times x minus x1. We had our x1 of -4, but we hadn't actually calculated y1. So I went ahead and did that, plugged those two numbers in, and the number that we did all the work for, 3, and then just finished it. But on the exam, you can stop right there. Numbers are in the formula. That is an equation of a line, and that is easier to grade. Now, if you do the rest of the algebra on the test, that's because that's your habit. That's fine. It's not wrong. You just don't have to. So, what questions do y'all have on that crazy mess? So, as annoying as the rational function is here, the algebra here wasn't as ugly as it was for the square root. So I think a basic rational function is probably what'll show up on this one on the test. So not A, did you know how to do it at the start? But looking at it now, do you think you could do a similar question just with a slightly different function? Or do you think you could practice it till you got comfortable enough with it? All right, so this one, it's a rational function, but it's a rational function that's squared on the bottom. Because of course, so same song, second verse. All right, so I'm gonna up top, since we needed to figure out f of -4, I'm just gonna work that to the side here. So that's, now notice here, it can be really easy to miss this stupid minus sign. I don't like this typesetting, but that is the habit in WebWork. And it is very easy to not see that minus sign. All right, so I plugged in -4 in place of the x. So -4 plus 2 is -2. So that is -2 in parentheses squared, which is 4. So -9/4. So that means the x1, y1 point is -4 for the x value and -9/4 for the y value. All right, now we're going to use our definition of the derivative. Okay. So our a value here is -4. So everywhere there was an a, I just put parentheses and I'm filling in that -4. I forgot to write the limit. So f of -4 plus h. All right, so again, I'm going to take that h on the bottom and I'm going to write it as 1 over h in front. And then I'm just going to have some brackets for everything that's on top because I'm about to have some annoying fractions. So -9 over thing plus 2 squared, where thing is -4 plus h. Minus, now f of -4 we worked out, that is our -9/4. So I have -9 over -4 plus h plus 2 will be h minus 2 squared. And then minus -9/4 becomes plus 9/4. Okay. So right now, if I plug in 0 for h, I've still got that 1 over h out front. still not in a defined form. So I have two fractions. I need to combine these fractions together. That means I need a common denominator. So we've got two different denominators here. So whatever is missing is what we're going to include. So for our front fraction here, I'm going to multiply by 4 over 4. And then for our other fraction, the 9/4, I'm going to multiply by h minus 2 squared over h minus 2 squared. So my denominators are the same, so I'm going to go ahead and combine them. So that is 4 times h minus 2 squared. On top, negative 9 times 4 is negative 36 plus 9 times h minus 2 squared. So on the bottom, I don't need to multiply out h minus 2 squared, but on the top, I do need to do that. So that's where we're going next. And in this case, that is a FOIL. So we have a negative 36 plus 9 times h squared minus 2h will be minus 4h. Negative 2 times negative 2 is plus 4. So still the negative 36, and then this 9 is going to get multiplied through. So plus 9h squared minus 36h plus 36 all over 4 times h minus 2 squared. So that negative 36 cancels out that positive 36. And now the other two terms left on top both have an h. So I'm going to factor that h out. So that's h times 9h squared. I need a 9h, so 9h times h is 9x squared. And then minus 36, so h times minus 36 is minus 36h. All right, so this h here times h cancels out that 1 over h. Now I can plug in my 0. So now that we're substituting in 0, the limit is gone because we're doing the actual evaluation now. So this is 9 times 0 minus 36 over 4 times 0 minus 2 squared. So negative 36 over 4, negative 2, 0 minus 2 is negative 2, negative 2 squared is 4. So 36 is divisible by 4. So that is 4 goes into 36 9 times, so negative 9/4. So the slope of the tangent line at -4 is -9/4. Pure coincidence that the slope of the tangent line is the same as the output value of the function. All right, so we did all that work, but we're not done. We still got to find the equation of the tangent line. Now remember, we had that work at the beginning. That was our ordered pair. So y minus y1 equals m times x minus x1. So y minus thing equals slope times x minus thing. So our y1 is -9/4. Our x1 is -4. And the slope of our tangent line is -9/4. Whole lot of crazy work. Now, the functions that we just worked through these last two, like they're good examples, but they are more complicated than what we would put on the exam. Like, not to say that you guys can't do this, but on the exam, I have to balance a good question against how long the question will take. These functions, because they've got more going on in them, make them take longer. If the function was more basic, you still have to do a fair amount of the work, but there's not as many extra numbers to deal with. So what questions do you guys have on how this one played out? All right. Our last one is just a summary. So the first questions you're going to have on web work are going to ask you to find the slope of the secant line. And that is literally just slope. So any of these formulas will work. Then when we're going to calculate the slope of the tangent line, that's when we apply the limit. So slope of the tangent line is the same thing as derivative, and that's what these formulas here are. Let's see. Sorry, I'm trying to dig around and find like weird questions. No, they're all really similar to what we just worked through. So let me open it up for any questions you guys have. Are there any questions on web work or the writing assignments? So we will give you the f of a plus h minus f of a all over h. Like we give you the definition of the derivative one, but we don't give you the equation of a line. So the y minus y1 equals m times x minus x1. Or if you want to do y equals mx plus b, like whichever way you want to solve it. 5. But, you know, as per usual, like each of those 5 have multiple parts. So like the first question on the test, it's very similar to the first writing assignment. We give you a graph with a whole bunch of crazy stuff going on. And we ask you to like evaluate a bunch of limits based on the graph. And then the follow-up is there's discontinuities in the picture. Tell me where the discontinuities occur and what type of discontinuity it is and why you know that. Trying to think what we did after that. Then we have just some algebraic limits. So just like normal, like at least one of them, you just plug in the number and it works. Some of the others, you got to do a little algebra work before you can get the result. Then we have a question that deals with continuity. So very similar to the writing assignment from continuity. Then limits at infinity. So one of them will be a rational function. So you've just got to remember, like, you know, how those limits at infinity for rational functions work. And then there's also going to be a weirder function. I haven't picked which function it is, but it'll like involve trig or e to the x or maybe both of those. And then the last one is going to be like what we covered today. Find the derivative at a particular value and then find the equation of the tangent line. So I tried to make the writing assignments like based off of the old version of the exam. And the new exam is going to be pretty similar to the last semester. So I'm probably still going to do one more writing assignment just so you guys can do practice on this kind of question. So I set the exam 1 practice problems. They're going to open tonight. But those will be worth bonus points on the exam. So if you only do like 92%, like if that's your score on it, then I'll add 9.2 points to your test score. So if you don't get all of it, you can still earn some of the bonus points. So it is absolutely worth working on those. Bless you. All right, well, my brain is like capped out. So I brought flowers because it's Valentine's Day at the end of the week, and giving flowers is a nice thing to do, but my purple one's kind of wilted. But if you would like to take a sprig of flowers for whatever reason, you can. They're here to share. So if you want to take it just to have one, because having a flower is nice, cool. If you want to take it to give to someone else, or if you want to take it to pretend you're going to give it to someone else and then don't give it to someone else and keep it, that's fine as well. Or if you just think this is weird or flowers are allergens and don't want to, that's okay too. Let me stop the recording.